All right, go and take out your textbooks and turn to page 420. Page 420, and you did the review, 9 through 14. You also did the practice, 12 through 28, the every other even. And most of you did page 124, the word problem, number 77. So turn in your books to page 420. We're going to start with the review at the bottom of the page. So on your homework, find where the 9 through 14 was. Thank you, sir. And there's the word problem. Good. There's the word problem. There's the 12 to 28 again. 14. Good. And your 12 to 28 even. All right. Page 420 at a 12 through 28 even. Every other even, excuse me. That looks like that there. You're supposed to have a 9 through 14. The review, that looks like that there. Sort of. And then just missing that word problem. So yes, if you'll finish filling out the green slip there. Page 420, going to take a look at the review first of all. And multiplying a couple of fractions together. The key to multiplying fractions is to simplify the problem as much as possible first. And to simplify, we like to cancel stuff away. But specifically, Noah, we cancel what? Factors. We never, class, would cancel away terms. We only cancel factors. And therefore, Maddie, the first step to solving this problem is to factor. We got to factor everything. And on number 9, that first numerator should have factored out a common factor x and then backwards FOILed. In the denominator, should have factored out a common factor of 5 and then backwards FOILed. For the next numerator, no common factor, just backwards FOIL. And the last denominator would have factored into 2 identical binomials or a binomial squared, preferably identical binomials. What did you end up getting after you canceled everything away, left what was supposed to remain? What was your answer here, Gavin?
Times x minus 3 times x plus 2 over 5x negative 2 squared.
Okay, had a little bit of a factoring issue then on one of your top trinomials. Let's go to Noah. What was your answer?
X times 2x negative 3 times x positive 1 over 5 times x negative 2 squared.
Okay, yes, it also had some backwards FOIL trouble there. Maddie, what was your answer? Also seem to have had a little bit of trouble. All right, let's go and take a look at the factoring here. Check your first numerator. You factored out the x, leaving you initially with the 2x squared negative x negative 6. I think this may have been where the problem was. You know the 2x squared has to be 2x and 1x. You know the signs have to be different. Probably 2 and 3. But you know you can't put a 2 with a 2, so the 2's got to be here, the 3's got to be here. And when you check your outer inner, this is what we should have had. I'm afraid some of us had a 2x negative 3 and an x positive 2. Check your work. Am I right? Okay, that outer inner, negative 4, positive 3, has to give you this. Here's what I think happened. You saw this and you said, well, that's negative 2. That's positive. It's not negative 2. It's negative 4. And I think the 2 threw you off. You're like, oh, negative 2, positive 3, but it should have been negative 4, positive 3 gives you the negative 1. So had you had that, and of course in the denominator, you pulled out the 5, getting you a 3x squared negative 5x negative 2. By the way, pause. 3x squared negative 5x negative 2? You mean 3x squared negative 5x negative 2? Mathematicians are lazy. Now, the problem is I do actually have to factor this because I have to know what factors are being canceled away, so I know what excluded values to put. But otherwise, do you see, these would normally completely cancel away. Okay, so this factors into 3x, 1x, negative 2, positive 1. I know this is also going to be 3x positive 1x negative 2, right? Okay, so save yourself a little time. How many noticed you had an identical trinomial so the factors worked out the exact same? Okay, Maddie made that observation. The more you observe, the easier life is. Of course, this is the x negative 2, x negative 2. So that these two will cancel, but these two will also cancel. The 3x plus 1's cancel, leaving us with the x, 2x plus 3 over 5x negative 2. And we did cancel a couple of x negative 2's, didn't we? but there's still another x negative 2, so I don't have to say x can't be 2. I do need to specify x cannot be a negative 1/3 because of 3x plus 1. So this is the answer we should have had on number 9. Let's see if we could rebound a little bit. Number 10, the factoring was a little bit easier. And Brecken, let's come to you. What was your answer on number 10 from the homework? Maybe works a little too messy to read, it looks like. All right, let's go back to Gavin. Gavin, what'd you get on number 10?
3 times x minus 1 over 4 times x positive 3, x negative 2.
Good, where x cannot be?
Negative 2 or positive 1.
Excellent job. 3 times x negative 1 over 4 times x negative 2, x positive 3, where x cannot be negative 2 or 1. Great job, Gavin. How many others had the same answer? All right, so a couple of you did not. Check your factoring again. 3 times x plus 2 over x positive 3, x negative 1. Reckon checking your factoring as well, right? And then x negative 1, the next numerator, and then 4 times x positive 2, x negative 2 is the final factored form for the second denominator. So again, canceling with the x positive 2's, canceling with one of the x negative 1's. There's your numerator, there's your denominator, where x can't be 1 or negative 2. Questions on 10. Did you find a mistake? Probably a factoring mistake. Check your outer inner on the backwards FOIL. Number 11 for redemption here. Noah, what did you get?
3x negative 2 over 3 times x negative 2.
No, Maddie was close though.
3x positive 2 over 3 times x plus 4.
No, but you were closer still. Brecken, what did you have on number 11?
I got x positive 4 over x negative 3. Not over. X positive 4 times x negative 3 over 4x times quantity x plus 2.
I think that's number 13 that you're looking at instead of number 11. I think you might be looking at number 13. Let's see. Man, we are struggling. Y'all have a quiz over this tomorrow, by the way. You better figure it out pretty quick, okay? Factor into 3x and 1x. Let's see, negative 2, positive 2. Yes, we'll give you negative 4. And then you pull out a 6. That's easy. That's just x positive 5. Pull out a 2 because you get x squared negative x negative 20. So that's going to give you an x negative 5x positive 4. And then pull, let's see, x and x. Let's go positive 4 and negative 2 would have been your factored form. Okay? Now, I don't expect you to do it that fast in your head, but I do expect you to be that accurate. I mean, I obviously have a speed advantage because I've been doing this for forever, right? But you have a brain that can do this math process. If not as fast, just as accurate, right? You've got to be as accurate. And then from there, cancel what you have left over. More accurate. Because we should have had a negative. That's a 6x negative 30. I was like, wait a second, I don't remember x negative 5 being in the answer. So x negative 5's cancel, x negative 2's cancel, x positive 4's cancel. 2 and 6 can cancel to give you the 3 and the 1 there. So that's it. In the top, all you have is the 3x plus 2. And at the bottom, all you have is a 3, where x can't be 5, x can't be negative 4, and x can't be 2. That's what we should have had for our answer. Okay, Gavin got it. All right, so Gavin's 2 for 3. All right. Third try's the charm, Noah. Fourth try's the charm, Noah. What did you get for number 12?
1 over a plus 2b.
Ah, it is the charm, and a cannot equal
Negative 2b, or negative b.
Oh, well, you got the main answer part right. You may have lost a point at the end of it. What's the excluded value there, Maddie? Good, negative 4b over 3. Should have been the excluded value. But 1 over a positive 2b. How many had 1 over a plus 2b for your answer on 12? All right, we were perfect on this one. Excellent. Other than maybe the excluded value. All right, going to number 13. And Maddie, what did you get for your answer? Actually, Brecken, you gave me your answer a minute ago on 13. It was really close. What was it again?
X positive 4 times the quantity x negative 3 over 4x times the quantity x plus 2.
It's really close, but something's just not quite right. Let's check your factoring on this one. Should have been an x positive 4x negative 3 for your first numerator, is that right?
Yes, sir.
All right, first denominator right below it should have been an x plus 2. Was that right?
Yes, sir.
Okay. Then you should have pulled out just an x times x plus 2.
Looks like I got one.
What did you have?
I just left it x squared plus 2.
Okay, and then in the bottom should have pulled out a 4x to get x negative 3. Okay, so probably then you also canceled some terms, if I'm not mistaken. So, yeah, careful here. If this were the factored form, Brecken, picking it up from right here, what should we have canceled away?
X positive 2's. X and the 4x.
The x and the x with the 4x, there we go.
X negative 3's.
All right, so what should have been our answer?
X positive 4 over 4 times x positive 2.
All right, and then what are my excluded values? I got 1, 2, 3 of them.
X positive 3 negative 2.
There we go, and that should have been our answer there. So I guess the thought there, Brecken, is good with the backwards FOIL. Don't forget about common factors, right? Get the common factors out. How many have the same answer? Here on number 13, all right? And number 14, let's go back to Brecken for redemption. What was your answer?
I got 1.
Yeah, everything cancels, so we just get 1. And the book includes excluded values of negative 4, negative 3, and positive 6, but what x is it that can't equal those things exactly? There's no x's left, right? So I would argue you don't have to have the excluded values there, but for sure, 1, our answer. How many also got 1 for number 14? 1 for number 14, excellent. All right, questions on that. So we started off kind of rough, but there toward the end, it seems like we got into a better rhythm there. All right, let's move up a little further on the page to the numbers 12 through 28 even. And we had been multiplying at the bottom of the page. We move up and now we're dividing. But Maddie, we're really still multiplying, aren't we? Because dividing fractions is really just multiplying by the reciprocal. What does it mean, reciprocal, Gavin?
Almost completely opposite, not completely.
There's a much easier, much more common sense way to express it. Noah? Flip it. All right? It means flip it. Now, which one do we flip for redemption, Gavin?
The one after the division.
Good. Not necessarily the second one, but the one after the division sign, right? So on number 12, I would not even write down number 12 the way it's written. I would write 5x plus 2 over 3, Gavin.
Times 6 over 10x positive 20.
There we go. We're going to write it down as a multiplication problem. Now, if you wanted to, you could write it down in factored form. That would be perfectly fine. And if I did want to write it down in factored form, what would I have written right here, Gavin?
10 times 20 x positive 2.
There we go. And that's the only factoring I can do. It's tempting, isn't it, to see the x plus 2 here and the x plus 2 here, but you see this x plus 2 is a factor. These are individual terms. They're not even grouped together, so no canceling here. The only canceling we really have, Gavin, is
6 and 3.
to get
1 and 2, and then cancel the 10 and the 2 to get 5x positive. Oh, that was just 5. It's 1 and 5.
There we go. And that's all you can cancel, right? So our answer comes out looking kind of interesting. What do we get for our answer here, Gavin?
5x positive 2 over 5 times the 20x positive 2.
Right, 5x plus 2 over 5, x plus 2. And the only excluded values is 3 can't be 0 and 2 can't be 0, but they already can't be 0, so we don't need to write any excluded values there. We didn't have a denominator turn numerator, right? That's another thing with division, remember, is if something's in the denominator, it moves up to the numerator and doesn't cancel away. You still have to specify that can't be 0. Didn't have anything like that. So there's our answer. How many had this for number 12 on the homework? Number 12. All right, questions. Did you cancel stuff you weren't allowed to cancel? Only cancel factors, never cancel terms. All right, so number 16. Worked out pretty easily for your answer. What did you get on number 16, Noah?
5 over 6.
Really close. Maddie? 5y over 6. If you look in your numerator, I think you'll see a y that didn't cancel away, and it hides, right? So 5y over 6. We do have a couple of excluded values though, so let's take a look at the problem. Should have factored x negative 4y, x negative 4y. Should have pulled out a 2 to get x negative 4y, and then flip it. So what was in the numerator moves down. We pull out the 6x negative 4y, and the 10y that was in the bottom moves up to the numerator. Of course, the x negative 4y's cancel cleanly. The 10 and 2 cancel to give you a 1 and 5, and there's your 5y over 6 answer, right? We do need to specify, Noah, that x cannot equal 4y. And then we look at right here where this used to be a denominator. If this were a denominator, we would know just by looking at it that y cannot be 0. But right now it looks like y could be 0, so we have to specify y can't be 0. How many had the complete answer, including excluded values, correct? How many at least got the 5y over 6 and maybe just missed the excluded values? All right, questions on number 16. All right, let's take a look at number 20. Number 20 worked out pretty nicely here. Brecken, what was your answer?
15 over x negative 1.
Great job. And your excluded value?
2 and 30.
Gavin?
Negative 3y over 2.
Should have been negative 3y over 2, and I think you had the right idea here. You had seen that this x plus 2x plus 3y had canceled away. And so when you set it equal to 0, you're like, well, 2 and 3, careful. We need to get one of the letters by itself, so either of these needs to move over. Presumably the 3y, so 2x cannot equal negative 3y, and then divide away the 2. Does that make sense how to get the excluded value there? But otherwise, great. 15 over x negative 1 is our answer. How many had this for number 20? Had this for 20. Okay, you did have it then, okay? All right, questions on number 20. Number 24, let's take a look at this one. That second numerator that's going to become a denominator, by the way, is 4 terms, which means it's going to have to factor class by grouping. Yes, we had to do a little factoring by grouping, but also we had that first denominator is not in descending order. So a couple things here. First of all, the x squared negative 16, Maddie, should just be rewritten. Right, x negative 4x positive 4, or x positive 4x negative 4, the way I usually write it. But that denominator, what did you do for that first denominator, Maddie? And when you pulled out the negative x, it gave you, careful, you have a 4x negative x squared. If you pull a negative x out of a 4x, what would it give you? And then a negative x out of a negative x squared, positive x. There we go. All right, then we're going to change it to multiplying. So what moves up here? The 3x squared. And then down here, we get that old numerator. Where if we group the first 2 terms of the old numerator, there's a common to give you. And then if you look at the next 2 terms, there's a common that leaves you with. And of course now there's a common that leaves us with m plus n. There we go. So a good review of factoring by grouping. From there, what could you cancel away, Maddie? No. Okay, this x squared cancels with this x, good. But there's one more thing, and it's in disguise. The x negative 4 cancels with the x negative 4 as well. So, what should our answer have been here? Good, because in the numerator there's a 3 and an x. Good, which we're going to put. And as far as our excluded values, well, we canceled away an x, so we also canceled away and x negative 4, which either of these would have worked, right? If I look at this one, just move the negative 4 over to get x cannot be. But also here, and the only thing that had moved up to the numerator was the 3x squared. There's this x here that can't be 0, but because of this x canceling, we'd already said it. This should have been our answer for number 24. Did anyone get this? For number 24 is a challenging problem between the grouping and the negative that had to be factored out. Gavin, you did. Excellent. Questions from the rest of you? Does it make sense now? How to methodically work through pulling out the negative. Now, I normally would have taken the 4x negative x squared and started with a rewrite of negative x squared positive 4x, then pulled out the negative x to get x negative 4 like this. I normally would have flipped it first, then pulled out the common factor, but you could have done it the other way. And the number 28 I thought was pretty straightforward, though the answer is not quite as pretty as maybe we would like it to be. What did you get for number 28, Noah?
X plus 2y over x negative y.
Good, where x cannot be.
Y, negative y.
Good, x cannot be negative y. There's one more thing.
0.
No? Anyone? Here's the key to division, remember. If it moves up and it doesn't cancel away, it has to also be set unequal to 0. So you did everything right, Noah. You flipped it, you factored right, maybe even grouped, you canceled the x plus y's, you canceled the 3's, you got x plus 2y over x minus y, you identified that x can't be negative y, but that used to be in the bottom. So we also need to say
X can't equal x negative 2y.
negative 2y. And that should have been our complete answer there. And how many got that for number 28? Number 28, nobody. All right, questions on the division with that flip and the non-canceled old denominator. Do we remember that now? But I'm going to go a little out of order here. I want you to go back now and do, let's do 10, 18, and 26. 10, 18, and 26 here on page 420. We'll take a look at that in just a little bit. Noah? Gavin? Monty? Make sure, while you have just a few more minutes to finish up, or just a few more seconds to finish up, double check, make sure if it was a denominator and it moved up to a numerator, that you specify that can't be 0. Pencils down. Let's take a look at these together. And number 10, pretty straightforward. What'd you get for your answer on 10, Maddie? Where? Good. X over 3, where x cannot equal 0. How many had the same thing on number 10? Excellent. Number 18, Brecken.
2 over 5.
Really close. Should have had a negative. Did you factor out a negative earlier? Make sure the negative makes it to the answer. That's hard, right, to catch that little negative. So negative 2/5. And again, the text would argue you need to specify x can't be 3 or 0. What x? But otherwise, good. How many had negative 2/5? All right, good. And then number 26. What did you get for your answer, Noah?
X negative 1 over 2, and x cannot be 1, negative 1 or 0.
Something's not right, but I'm not sure what you did. Gavin? What'd you get for your answer?
X negative 1 over 2x. X cannot equal positive or negative 1.
There we go. X negative 1 over 2x, where x cannot equal positive or negative 1. So we actually didn't need the x can't be 0. Should have factored x squared plus 1x squared negative 1. Should have factored 2 times x squared negative 1, which is x plus 1, x minus 1. But I'm just going to allow these to cancel like that. Times x negative 1 over x times x squared positive 1, where the x squared positive 1 also cancels. Of course, the sum of squares doesn't factor. So there's the x negative 1, there's the 2x. And again, if you were to set this unequal to 0, you'd say that x squared can't be negative 1, but a squared can never equal a negative anyway. So we really don't need to worry about that. Here, x negative 1, x positive 1, neither 1 can equal 0, so therefore x cannot be the negative, positive, or negative 1. But that should have been our answer. How many at least got the, even if the excluded values cause you some problems, got the x negative 1 over 2x? Okay, Maddie question, Brecken questions. All right, let's take a look at the word problems now. Back to page 124. You did word problem 77, most of you, for homework or over the weekend. Page 124, word problem 77. And go ahead and read that word problem for us if you would. Gavin.
Morgan and Kendall began jogging at the same location and jogged in opposite directions. Morgan's rate was 1 mile per hour faster than Kendall's rate. After 2 hours, they were 21 miles apart. Find the rate of each.
We need to set up a chart, and in our chart needs to be what 3 headings?
Speed times time equals distance.
Good. How many set up the chart with speed, time, and distance as your 3 columns? And we are clearly told the time that each spent running. And by the way, I have never run for this long or jogged for this long. How long did they jog? 2 hours, both of them. At least that's what they said, okay? It doesn't tell us there's a fact checker here to make sure that it's really true. Yeah, 2 hours they jogged, which is really impressive. I've never jogged for that long. Not continuously, at least. What does it tell us about their speeds?
That Morgan per hour faster.
Right, Morgan ran 1 mile per hour faster, so who gets to be X?
Kendall.
Kendall, because if Morgan's 1 mile per hour faster than Kendall, Morgan is.
X plus 1
So how far then must Morgan have run?
mile faster.
No, that's how fast. She ran a mile per hour faster than Morgan, but if she ran at a speed of X plus 1 miles per hour for 2 hours, how many miles did she run?
2x plus 2.
Good, 2x plus 2. And how far did Kendall run if she ran at X miles per hour for 2 hours?
2x.
Oh, I say ran, jogged. 2x total miles. How many had the chart completely right? All right, question, Maddie. Okay, so you had Kendall going 1 mile per hour faster than Morgan, okay? And to be fair, no, not to be fair, because it really, okay, I was remembering incorrectly what it says. It said Morgan's rate was 1 mile per hour faster than Kendall's rate. Comes back to Kendall's X. All right, now, it says they both start at the same place, but they jog in opposite directions. The one goes a distance of 2x plus 2 miles. The other goes a distance of 2x miles. But at the end of 2 hours, they are 21 miles apart. What should the equation be, Maddie? Good, because they're going in opposite directions, you would have to add the distance of the one plus the distance of the other to equal the 21 miles. Do we see that? Will we always add the two distances? No, because this isn't always a total distance, but it is here. So we'll combine our like terms, Maddie, and at the same time, let's ditch the 2 as a, to get, and it doesn't work out evenly, but that's okay. We end up getting x is equal to, should have been 4 3/4, correct? And so that's the speed that Kendall ran. We don't round. It should have been the speed that Kendall ran. So Kendall apparently ran how fast? Or jogged how fast? But Morgan jogged 1 mile per hour faster. She apparently jogged at a rate of. And was that the question? What was the rate of each? Yes. So all I asked for was how fast was each girl going. How many got 5 3/4 miles per hour and 4 3/4 miles per hour? All right, only Gavin. You were on the right track. Did you get the right equation?
I did the same thing that Maddie did. I rounded.
You rounded? Oh. All right. Don't round. Got it? All right, questions on the word problem. All right, Brecken, didn't do it, should have did it, but does it make sense? All right. Let's look up just a little bit right above it, number 75, and Brecken, go ahead and read this one for us.
2 walkers, 16 miles apart, travel toward each other. One travels 3 miles per hour and the other 4 miles per hour. If the latter is delayed 3 hours, how many hours before they meet?
All right, we've seen this word before, latter. What does latter mean again, Brecken? Do you remember? Noah, help him. What does latter mean? All right, so remember, in the terms former and latter, if you're talking about two people, former refers to the first one you mentioned, latter refers to the last one you mentioned. So if I said, Brecken and Noah are going to go play in the basketball game this afternoon in Opelika. Did you hear I said Brecken and Noah? All right, who would be former, class? Who would be former? Brecken, because he was the first one mentioned. Brecken and Noah. Who would be the latter? Noah, because he was the last one mentioned. All right, so when it says that the latter is delayed 3 hours, which one is the latter, class? The 4 mile per hour dude, right? The 4 mile per hour person is the latter. All right, so let's go ahead and list them this way. We'll use their term here, former and latter, because it doesn't differentiate between the two walkers here. And we have a speed, a time, and a distance for each. First of all, the speeds are clearly spelled out for us. The former travels how fast, Brecken?
3 miles,
and the latter.
4 miles.
The difference is the time that each one is going to travel. Because it says that they start out and they're like, all right, you're here, I'm here, you know what, let's go for a walk and we'll meet up whenever we meet up. And the one guy's like, all right, let's go. And the other one's like, but let me take a nap first and then take a shower. And I don't know, maybe it's like, maybe there's this guy and this girl and they're like, you know what, I know we live 16 miles apart, but if we just keep walking, we'll eventually meet each other. And the guy's like, I'm leaving now, baby. Me too. And so he heads out and she's like, my hair's not done. And so 2 hours later, the hair's done. My nails aren't done. And so another hour later, the nails are done. She's like, no, I'm beautiful. And so now she walks and she's like, oh no, I'm late leaving. And so she walks really fast. Okay, I don't know. Maybe that's how it goes. And he's like, I want to go meet her, but I want to save my energy. Don't want to walk too fast now. So he's actually walking a little bit slower. Maybe that's the scenario. The problem doesn't tell, so it leaves a lot to the imagination here. All we know is that the ladder is delayed 3 hours. What does that tell us about the time each travels? Anyone? Good. The former just starts out. How long does he walk or she walk? We don't know. X. But the other person doesn't even start till 3 hours later. So the other person apparently walks 3 fewer hours. Make sense? Assuming that they just keep walking until they meet up. So X minus 3. Anyone thinking the same thing Gavin said? Gavin gets the credit for saying it. How many others thinking X and X minus 3 already? All right, if not, does it make sense now? So question, how far does the former walk? 3x. Someone besides Gavin, how far does the latter walk? Good, 4x negative 12. Now, there's one number we haven't used yet. What's that last number, Brecken? Back to you.
16 miles.
So, former and latter are 16 miles apart, and they must be together. So the former walks 3x miles. The latter walks 4x minus 12 miles, and they finally meet. All right? What's the equation going to be here, Brecken? Good, because you have to add their collective distances to equal the 16-mile distance between them that they had to overcome. How many were thinking the same equation, Brecken said? Do you see how a quick, simple sketch can help you to figure out the equation? Let's solve very quickly. Add the x's together, Brecken. Let's ditch the 12 as a... It is a negative 12, so move it over as a positive 12 to get 28. And divide both sides by 7, class, to get x equals. Now, what did x represent? The former's time. So apparently the former walked for how long? How long did the latter walk? 1 hour. But how long was it before they met? It was 4 hours, right? Even though the latter was delayed 3 hours in my illustration doing her hair and nails, and she only maybe walked for an hour, it still took 4 hours between let's get together and there you are. Okay, it took a while, like 4 hours still, even though she only walked for an hour. So the former walked how far? 3 miles an hour for 4 hours. How far? 12 miles. Where the latter only walked 4 miles. But because she didn't walk as long, she looks great. All right, anyway, questions on the problem. Questions on the problem. All right, turn back to page 420. Turn back to page 420. I want you to do numbers 11, 15, and 21 as we practice back with our division again. As I mentioned before, getting ready for a quiz tomorrow over multiplication and division of fractions. So numbers 11, 15, and 21. They're on page 420. I'm going to turn the heat off because I'm about to die. Suffocating, as it were. You have a Lauren, right? She just didn't dress like her? 11. Oh, okay. As you finish checking your answers, if it's circled, if the excluded value is in the circle, it must be included. If it's not in the circle, you could say it, the book would say it, I don't necessarily say it. But it's not wrong to say it. Maddie, good to go? All right. If you finish and you've checked your answers and they are correct, go on and do 19 and 27. So once you finish those first three and you've checked your answers, go on to 19 and 27. Of course, if you have questions on these at all, be sure to raise your hand so I can answer them. You good to go? And Noah, you found something. What did you mess up?
For 15.
Okay.
I put x cannot equal positive 3 and 0 also.
I mean, you could say x can't be 0, but x obviously can't be 0 because it's still in the denominator, and you just forgot to change the sign you said on the -3. Yeah, I wouldn't dock you points if you said x can't be 0, because it's true. It just doesn't have to be said because it should already be obvious from the answer itself. All right, good. Go on to 1927. Brett can finish with those first three and check in answers now. All right, good to go, or did you find something? Got them all. Excellent. Good. Go on to 19 and 27. You can pause the video if you need more time. We're going to move on. Alrighty, already finished. For sake of time, stop where you're at. 27 is insultingly easy anyway. If you kind of look at 27, the white one on the right-hand side, super easy. More concerned about number 19, getting the order reversed by pulling out the negative to give you a positive x and a negative y. And the fact that this y used to be a denominator, but it moved up, so we need to specify it can't be 0. So a couple little things in number 19. How many got number 19 outright? Okay, good. Questions on 19. Questions on 19. All right, anyone get to 27? Get that one done? All right, did you get it correct? I'm assuming so. Number 27 was really easy. 19 was the one I was more concerned with. Questions at all on 19? All right, your homework this evening is to do page 425. Page 425, numbers 5 through 10. Page 425, numbers 5 through 10, and page 130, review number 7. It's a word problem. Page 130, the review number 7. So page 425, numbers 5 through 10, a practice of multiplying and dividing fractions in preparation for tomorrow's quiz, and page 130, review number 7. All right, you are dismissed. Have a wonderful rest of your day.